Welcome to Snowflake. This video focuses on the architecture and key concepts of Snowflake's Cloud Data Warehouse. Snowflake is an all-new SQL data warehouse built for the cloud. Snowflake runs on the Amazon Web Services cloud. Delivered as a data warehouse as a service, Snowflake handles all aspects of software configuration, resource management, availability, authentication, data protection, tuning, optimization, and more. Customers simply sign up with Snowflake and start using it. How does Snowflake differ from other traditional architectures? Traditional shared disk architectures use multiple nodes in a single cluster to access data shared on a single storage system. Shared nothing architectures store a portion of the data in each node in each cluster in the data warehouse. Snowflake combines all the benefits of these architectures in an innovative new design that takes full advantage of the cloud. Snowflake's multi-cluster shared data architecture consists of three separate layers: data storage, compute, and a services layer that manages it all. Each layer scales independently and includes built-in redundancy. How does it work? Let's take a deeper look at each layer. Snowflake organizes data into logical databases containing one or more schemas. Each schema contains tables and views. Like standard SQL databases, Snowflake stores relational data in table columns using standard SQL data types. Snowflake tables can also natively store non-relational semi-structured data, such as JSON and Avro, using Snowflake's variant data type. Non-relational data is optimized and accessed through SQL, just like relational data. Snowflake stores all database data in Amazon's S3 cloud storage. As data is loaded into tables, Snowflake converts it into an optimized, columnar, compressed, encrypted format and stores the data in Snowflake's private S3 buckets. The compute layer is where queries are executed in Snowflake using resources from Amazon's EC2 service. Unlike traditional architectures, Snowflake's architecture allows users to create multiple, independent compute clusters called virtual warehouses that all access the same data storage layer without contention or performance degradation. Snowflake handles all aspects of provisioning and configuring the compute resources. Users create virtual warehouses and specify the size of each. Each virtual warehouse processes queries sent to it by users and applications. A virtual warehouse can start processing queries as soon as it is provisioned. A virtual warehouse can be scaled up or down at any time, without any downtime or disruption. When a user resizes a virtual warehouse, all subsequent queries take advantage of the additional resources immediately. Snowflake's unique cloud architecture enables virtually unlimited scale and concurrency without resource contention. For example, different virtual warehouses can handle loading and querying concurrently. Because each virtual warehouse accesses the data storage layer, any changes to data are written directly to the storage layer and become immediately available to other virtual warehouses. The services layer coordinates and manages the entire system. It authenticates user connections and manages sessions, secures data, handles virtual warehouses, manages metadata, and performs query compilation and optimization. The services layer is fully managed by Snowflake and runs on resources distributed across multiple AWS availability zones to ensure high availability. The services layer also coordinates data access and updates across all virtual warehouses and databases, ensuring that once a transaction is completed, all virtual warehouses see the new version of the data, with no impact on availability or performance. Users can connect securely to Snowflake through any of the provided clients, such as our JDBC and ODBC drivers. A growing number of external tools include native connectivity with Snowflake. Snowflake also provides a command line client and web-based user interface. Almost all operations in Snowflake can be performed through these clients using SQL commands. What do you need to manage Snowflake? Not much. Unlike most database systems, Snowflake eliminates almost all knobs and tuning parameters. With Snowflake, users create databases, schemas, and tables, create virtual warehouses, load and query data. Snowflake handles the rest. To illustrate the different layers working together, let's walk through the life cycle of a query. Queries are sent to the services layer using any supported client or interface. This layer validates that the user sending the query is authorized to access the data and perform the operation specified by the query. Snowflake then creates an optimized query plan. Next, the services layer sends query execution instructions to the virtual warehouse being used by the user. The virtual warehouse requests from the data storage layer any needed data and executes the query. Results are then returned to the client. What does it cost to use Snowflake? Pricing is based on usage. You pay for the amount of storage and hours of compute you use. Storage cost is based on the amount of data stored in database tables after compression, plus the additional data retained to support Snowflake's unique data recovery features. Compute cost is based on warehouse size and the number of hours it runs. For full details of Snowflake pricing, see snowflake.net. This concludes this introduction to Snowflake's architecture and key concepts. For more details, see the other videos in the Getting Started series and the Snowflake documentation.